Now here is your next question, that's question number 20, and it also has 3 parts. And along with that, it also has internal choice. So let us solve this question one by one. We'll have first part, what type of drug is used in sleeping pills? So if I talk about sleeping pills, generally tranquilizers are used. We can simply write this as tranquilizers are used in sleeping pills. By writing this, you will get 1 mark for this question. After that, next part, what type of detergents are used in toothpaste? So basically in this case, we have to identify the type of detergent here, and in case of toothpaste, anionic detergents are used. And if you write so, you will get 1 mark for this part also. After that, why the use of Elitame as artificial sweetener is not recommended? While writing this, you can simply write that the control of sweetness of food is difficult in case of Elitame because this is very much sweet, and hence its use as artificial sweetener is not recommended. And if you write this reason, you will get 1 mark for this third part also. So total 3 marks you will obtain if you choose this internal choice and attempt in this way. After that, internal choice is also there. Let's take that. Define the following terms with a suitable example in each. Again, the question based on chemistry in everyday life. So here we have 3 sections. First, broad spectrum antibiotics, you have to define it. Further, disinfectants, and the third one, cationic detergent. Let us define them one by one. So first is broad spectrum antibiotic. Simply you can define it as these are those antibiotics which kill or inhibit a wide range of gram-positive and gram-negative bacteria. These are called broad spectrum antibiotics, and you can give one of these examples like chloramphenicol, either this or vancomycin or ofloxacin. One of them you can give as the example. So 1 mark will be awarded if you do so. Half mark for writing this definition and half mark for the example. After that, disinfectant. You have to define this. Disinfectants are the chemicals which either kill or prevent the growth of microorganisms. And in this case, example, either chlorine or sulfur dioxide. If you answer this in this way, you will get full 1 mark, half mark for the definition, half mark for example. Then the third part, cationic detergent. In case of cationic detergent, you can write that they are quaternary ammonium salts of amines with acetates, chlorides or bromides. Anions are there in this form. Further, example you can give here, cetyl trimethyl ammonium bromide. This would be the example. And if you write in the similar way, once again you are getting 1 mark, half for definition, half for the example. So total 3 mark for question 20 you will obtain if you choose this internal choice. I hope this question is also clear to you, and now it's a turn for next question, that's question number 21. Once again this question has 3 parts. It means it's a 3 marker question once again. Out of CH3 whole thrice CBr and CH3 whole thrice Ci, which one is more reactive towards SN1 and why? It means you need to just mention the more reactive compound as well as you have to mention the reason for that also. In the second case, write the product formed when paranitrochlorobenzene is heated with aqueous NaOH at 443 Kelvin followed by acidification. Further, third part is there. Why dextro and levorotatory isomers of butane-2-ol are difficult to separate by fractional distillation. This is 3 marker question as I have already told you. Let's solve it one by one. So if I talk about these 2 compounds, one is CH3 whole thrice CBr and CH3 whole thrice Ci. In this case, there is carbon bromine bond and carbon iodine bond is there, and you need to just identify more reactive compound towards SN1 reaction. You can simply answer this question by writing that the compound which is more reactive is CH3 whole thrice Ci. And what would be the reason? The reason is reactivity towards SN1 depends upon the ease of formation of carbocation. You know that it is a two-step process. In first step, there is the formation of carbocation, and that step is the slow step. So, how easily carbocation is formed, rate of reaction would be dependent on that. Further, since Ci bond is weaker than Cbr bond, hence in case of CH3 whole thrice Ci, carbocation will be formed easily because this bond can easily be broken and carbocation can be formed more easily, and that's why the rate is more towards SN1 in case of this iodo compound. And if you write in this manner, you will get 1 mark for this part. After that, there's next part. Write the product formed when para-nitrochlorobenzene is heated with aqueous NaOH at 443 Kelvin followed by acidification. So, in this case, you just need to write the reaction sequence. So, you should write here this reaction sequence in this way. First, what we have taken? Para-nitrochlorobenzene. This is the reactant. Now, it is treated with aqueous NaOH at 443 Kelvin. You will obtain the sodium salt of para-nitrophenol, and further, it is acidified to give you para-nitrophenol. So, final product that you will obtain here is para-nitrophenol. Two-step reaction it is. It means half mark for first step and half mark for the second step. It means total marks, those you are just going to obtain here, is 1. After that, next part, why dextro and levorotatory isomer of butane 2-ol are difficult to separate by fractional distillation. If I talk about dextro and levorotatory isomers, these are optical isomers, we know that, and optical isomers are having the same chemical properties, as well as if I talk about the physical properties, almost all the physical properties are same except the nature towards plain polarized light. That is the difference there. So, simply we can answer this question by writing that dextro and levorotatory isomers of butane 2-ol are enantiomers. And if these are enantiomers, they both have same boiling points, and if their boiling point is same, you cannot separate them by fractional distillation. So, here it cannot be separated by fractional distillation. This is the reason, and if you write the same reason, you will get 1 mark for this part also. It means question number 21 we have attempted well, and now it's the turn for the next question. Here is the turn for question number 22. An aromatic compound on heating with bromine and KOH, potassium hydroxide, forms a compound B of the molecular formula C6H7N, which on reacting with CHCl3 chloroform and alcoholic KOH produces a foul smelling compound C. Write the structures and the IUPAC names of compounds A, B and C. This is the question which is based on the given data, and here the reactions you should know. If I talk about the first reaction, aromatic compound you have, and on treating with bromine and KOH it forms a compound B with the molecular formula C6H7N. It means there is the formation of an amine. And if we talk about these reagents, generally in case of Hofmann bromamide degradation we use these reagents. So, the hint is here further. This compound, it may be an amine, on treatment with CHCl3 and alcoholic KOH produces foul smelling compound C. It means this is the reaction which is carbyl amine reaction, and in this case there would be the formation of a foul smelling isocyanide. So, hint is clear. On the basis of this you can solve this reaction. Let's check what is the first hint. Aromatic compound it is, treated with bromine and KOH, giving you the product that is C6H7N, that is the molecular formula given here. And if this is aromatic, definitely it would be the derivative of benzene. It should be C6H5NH2. This is amine, basically aniline. And when it is treated with chloroform and KOH, it produces foul smelling compound. So, simply we should know that A is benzamide. Further, if we talk about B, this is aniline, and here is foul smelling compound phenyl isocyanide. We have to write the structures as well as their IUPAC name. So, you can answer this question by simply drawing the structures and writing the IUPAC names of these compounds. The first one benzamide, you can clearly see. Further, aniline or benzenamine, And after that there is benzene isonitrile or isocyanobenzene. The IUPAC names are clearly written here. For the phenyl isocyanide you can also write. So name of these will give you half mark and structure of this will give you half mark. It means for this part you will obtain 1 mark for writing the name and drawing the structure. For this part you will obtain 1 mark, and for this also you are going to obtain 1 mark. You should write one of the names among all these, not all the names. I hope this question is clear to you. Now after this it's a turn for question number 23.